they are gonna shut down by for 2 days, I guess.
So during the weekend probably, and then
Maybe,
for
yeah.
next week they should be fine, okay.
Yeah.
So then it should not
But
be.
he expected to delay for it also.
And your calculations, again, even for this week, you probably will be done with some of your calculations, even before the maintenance dates.
Okay, one thing is important, I guess you did all calculation in Thunder. Thunder, I can see it. Cluster. Okay, then you're fine.
Yeah, I haven't touched them.
Okay, because then you need to download all this.
And you, of course, I don't know if you need discussion with Jeb, but we have a lot of space now in our lab, so just come and work in the lab.
Yeah, he works some computational chemistry work in our lab using one computer here.
Yeah. Okay. So you can just continue doing what you were doing for the rotations.
So what we will do today, I'll do a little announcement twice because some people are coming at a later time. Then we will listen to Jabet for about 40 minutes. And then we will invest time in preliminary work on papers. So I will give announcement.
So today, just one, right? Erin?
Huh?
Just
No,
on
no.
Erin thing?
No,
We have more.
3.
3?
Yes.
Wow. Okay.
Yeah, for figures, it's like 10 minutes per paper. So do not look on me as a crazy. I will do the same thing twice. So let's congratulate Braden with best poster award. And let's congratulate Dr. Han with postdoctoral doctor. Today, authors and all the rest of semester, authors will distribute segments of their papers to everyone. Like 10 authors, 10 papers, and each of us will play 2 roles. First as author, second as reviewer. So you'll get a small portion of like 10 papers, and you will look through them and fill the grading form. Right? Since there will be many papers, you will do it very, very quickly. If you have time, if you are very inspired editor and reviewer, you can also mark something on the paper itself. But sometimes there is no time for this. I will talk more. This is a way to avoid unnecessary criticism of true reviewers on possible weak sides of papers. So if you look on the works of each other, it will be mimicking real life when reviewers are picking us on some short things. So I suggest before I quickly go once and then second time in an hour. So today we are just starting. True work on most of the papers will be next time. And when you look on the figures, you do just a second. So when you look on the papers, you may mark if you like the order, logical order, and everything you write forms around figures because those are main results. And if you do not see logic, if you see them random, you mark it to the author. Then it's not scientific, but it is a thing that irritates reviewers all the time. Make sure that all labels are in the huge font, and through all figures, the fonts are the same. Your great science can be postponed because of these inconsistencies. And do not write left, right if you have multi-panel. Label them alphabetically. Panel A, panel B. It's nothing wrong scientifically, but it is easier to process, and it is kind of standard. So each figure is followed by captions, and it is your chance actually start describing what you're doing. Do not hesitate to write long captures. If someone tells you they're too long, you can shorten it later. But for yourself, just in a kindergarten, what I see on this picture. So make it self-explanatory so that if some lazy reader doesn't read text, he or she can look on the figure and caption and understand everything. Also, if you have seen through publications, all your nice one-page figures are shrinked into 1/4 or 1/8 of a page, so it should be seen after substantial reduction. And if you do not see it, mark it to the author. And number of figures. Optimal paper cannot have 100 figures. It's even hard to have 10 figures. So you may suggest to move some unnecessary information to supporting information, or if figures do not look logical and in the right way explaining the story without word to yourself, you may suggest to author to add more figures to explain. So with your sense of beauty, give advice to the author. I will repeat it once again when it will be time, and I'm going to distribute several copies right now, but do not look on them. Put all of your focus and all of your attention to what will be presented by Jared. Just to save time, and I'm going to distribute those. So I'll distribute a couple of these forms, and then we'll arrange distribution of the works from authors to reviewers, with understanding that all feedback is returned to authors right after completing this reading. And Jared will not be able to make comments during his presentation anyway.
So, one page, how many?
No, it is one page per work. So 3 to everyone and just one extra, just in case.
Huh? Just one page?
Huh?
Like I have how many? 4, 3?
Yes, it is expected so.
Four.
So they're
No.
different, they're not the same?
No, they are the same. They are the same. So next time when will be more papers, probably each author will distribute his or her works. Right now I'll do it alone so that we do not run around.
Yeah, I printed my slide actually.
Oh, excellent. Thank you, Jared. This is a good idea. So the best figure is number 8 in the work by Aaron. If you do not have enough of cheerful mood today, look at his figure number 8. Oh, you already have it?
I don't know. Yeah.
Javid, do you have your presentation?
Yeah, I need to just download it.
And next time we all may want to staple our works. Okay. John, do you see Jabet? Oh, what do you do? Your presentation was.
Yeah, it's already there, so whatever, I downloaded it again.
If Jabed steps in front of the screen, I will be able to see him.
Okay. I will play a bit. What is this?
Oh, this is actually supporting information. I just printed 2 copies, but I did not print for everyone. I thought that. This.
What is this?
That's for supporting information for yeah.
So this is your figures or?
Yeah, mine.
Oh, okay. John, do you see Jabet better now? Okay.
Wait, oh, yeah.
Yeah, I do.
Perfect.
So, okay, thank you guys. So this is actually a presentation for, I wrote a manuscript for published in the nanomaterials and bio, I forget the exact full names of the journal in this one, to present on this one. And this is a study, mainly this study for the ligand types and the effect of the photophysical properties on the silver 5 and silver 6 side of the nanocluster. So I didn't actually put all figures and everything here, because otherwise it's going to be a very large slide. So I included only those figures which I'm going to put on the main paper here. And I changed the leveling and other stuff to fit on the slide size. So this is actual size for presentation too, for paper. For first, if I agree, this is a very typical outline for the paper. And in the first section, actually introductions, but for introductions, basically the 2 parts. In the first paragraphs, I tried to describe the motivation behind these studies, and then I talk about the, like, in original paper manuscript, I talked about like what I've done already experimentally as well as the theoretically, and what they found, and what is the necessity to do further studies, and how would helpful to get the silver nanocluster and synthesize this one. And the next segment is a methodology. It's all discussed about what methods I followed and software and all other things. And the resultant discussion sections, they have mainly 4 parts. In the first one, I tried to figure out what's the importance of using the solvent in this system actually, because I saw that most of the computational study, they use the did all calculations in vacuums, and also when you use the single strand DNA, is going to be a very hard to get the global minima, I mean very lax geometry. So I tried to justify our works, our system, how it's produced better result on this one. And then in the next segment, I discussed about the different types of passivations. Like I consider the 3 different types of ligands, nucleotide ligands for cytosines, guanine, and thiamines. In the next, I discuss about the binding energy dependence on the geometry and the ligands, and following on the photophysics of these all different types of cluster. And last section is just conclusions of this one. So motivation is behind this one because people are very interested in small scale silver nanocluster because.
Yeah, but your task just talk about introduction part of your paper, right?
Yeah, in paper I put everything in introduction. So I just in the first paragraph introduction I just.
No, but focus just on the introduction, right? Don't go to the results and so on, right? So you just give us the outline what will be in your paper. That's enough, right? And now,
just only introductions.
Just only introduction, yes.
Oh, okay.
Only introduction.
Oh, okay. Then.
Motivation is fine. It should be an introduction.
No, but in whole slide, I just focused on my whole paper and trying to discuss about result and everything. Okay, then maybe my
Well, then reduce it and go only through the introduction.
Ah, okay.
It has to be there anyway, right?
Yeah. So in introduction part, then actually I need to go through and show the manuscript because I didn't put all introductions and every options in the slide. So I just put as a one slide for introductions because I didn't focus only on the.
It doesn't matter how many slides you have. Just talk, right? If you know.
Okay.
What you have in your introduction, you can talk about it.
Okay. And I have also that as well. So for motivations, actually, in the before the introduction, just importance of this nanocluster, or especially silver nanocluster, because it's give you the structural base photophysics. Absorptions can be changed, depends on the structure, shape, and structure. So that would help to some imaging properties like use as a biosensor. But when they use a but when you're going to use as a biosensor, it's important because in biosensor imaging, it can produce a lot of background signals. But is they figure out that this silver nanocluster can be used to screen the specific signals, which can help to study the escape the all background noising. So that's also another importance of the silver nanocluster things. But smaller things, few atom nanocluster synthesizing is very hard because of agglomerations and their reactivity. So one of the most popular specification is like single strand DNA. So by using the single strand DNA, they are capable to synthesize nanocluster. But problem is, based on the sequence of the single strand DNA, it can change their photophysics properties, can increase the intensity, also the energy too, emission energy too. So it is necessary to study the interactions between the different ligands. If we know that a specific interactions, then we can say we can design the specific desired properties of silver nanocluster. We can control the photophysics properties. So because of that, we need to study how a specific cluster nucleotides react to the silver nanocluster. So in introductions, I just took actually few steps from my discussion introductions part. I included a lot of few more. So in experimental studies, there have a lot of studies happen. And one study they found that they are able to synthesize the green emitter by using only cytosines nucleotide DNA. That means this single strand DNA they have only 20 cytosines. So it's specified by only cytosines, and it's emitted like in the green one. But in another studies, interesting studies, and that's also worked by Jennifer from the National Lab, and also they use the enhancer. So this means they first synthesize the DNA singles nanocluster by using the single strand DNA, where more number of nucleotide cytosines. That was like red emitter, but intensity was very, very small and very, very low. And interesting thing is when they added the guanine single strand DNA with that one, with the previous pacemated single strand DNA, they saw the intensity increases like more than 500-fold. So that's guanine-rich DNA doesn't pacificated or interact directly with the quantum silver nanocluster, but it can increase the brightness too. And there have another work.
Since you're planning to do paper, and some people are not very well for getting text, you may summarize this idea in
a picture image,
graphical form. For example, you draw bare cluster and write AG only. Then you draw photon coming and then heat coming out. And then the second portion, you draw a cluster with like DNA coil around, photon coming, and another photon coming out.
So you can think that you need to have your how's it called, graphical abstract, right, for the paper. So this would be kind of main idea, what is the most important, right? So you put it in and you can start with a few drafts, right? Like break it into parts, and then you can connect them in one figure later on, right? But all this what you showing now can be really used then in a graphical abstract. And before you go, can you return back to your motivation slide? Since we talk about the paper, right?
Yeah.
So you saying, well, we are studying silver clusters because they are blah, blah, blah. And you have all your bullets here, which I don't have any questions about what exactly is there, but I still don't understand. So what exactly are you going to study in this? Like, what is the challenge? What is the open question? What exactly you addressing in your studies? Why, like, everything this is known already, right? Then what exactly is the purpose of your paper?
My purpose of our paper is like to get the specific interactions of this each ligand, how each ligand is changing.
Before you go to there, why is it important? Why is it needed?
It's needed if you wanna control the emission energy, or if you wanna control the photophysical properties.
How
we need to use.
How you know? Do you have any literature showing that changing something, you change the output for your signals or something?
Yeah, that's in the introductions part. I'm just showing the 3 examples here how it's changing the photophysical.
This example, well, in paper it's very important that you have a really logical order, right? And logical ideas. So far I'm completely lost because now you, like this, what you're showing, and in a way how you discuss it. You're just discussing why you're choosing these specific ligands on your silver cluster, like why you're choosing cytosines. At least this is what I got from your discussion. But it doesn't really answer the question, what are exactly your open questions, and how exactly these questions will help whatever you had in your previous slide with your motivation. Can you connect it?
Yeah, in the first slide is saying that cytosine can give us a fluorescence.
No. Return back to your first slide. There is no any words about cytosines or anything, right? It's just saying something about DNA, single-strand DNAs, blah blah blah.
In motivation, it's just overall silver cluster. Then I focused on. In later paragraphs, I just focused on how ligands dependent fluorescence can change with the ligand.
No, but you have your last bullet, right? For the physics of silver nanoclusters can be controlled by DNA strand, right?
Yeah.
So you have evidences of this. And when you say controlled, it means people know. If you use this, you will get that. If you use that DNA, you will get that. Is it really true? Because if it's known, then I don't understand what you're going to study.
But
what exactly your open question if it's already like, it is possible to control. So it's possible. There were already the work done, period, right? It's not a question anymore.
They found that different emission energy, but they don't know how it's changing. They just got it, but they didn't control
then
it
maybe this
specifically.
is the main point for your motivation. So like after your bullet, photophysics, blah blah blah, can be maybe not controlled, can affect, right?
Okay.
Because controlled means you really have a control. You know how to do the things. Here, it just they found out that you're changing strand DNA or you're changing some conditions. The response is changing as well, right? And you need probably kind of some citations exactly to that point.
Yeah, I have a citation.
Which might be from the other slide, but it's exactly to that point.
Yeah.
And then you say, well, but we don't know how to control it, right? So it just was empirical knowledge that changing something, changing this response. But what is exactly how exactly this happens? What exactly is the mechanism of interaction? What exactly from DNA part interacting with the surface, right? So this has to be done in motivation as like really your big paragraph, and of course it has to be in your any presentations as well, to say what are open questions, right? After this bullet you have to say, but there are open questions, right? We don't know how to control, and calculations can help with it. And then you go to the ideas, well, the first thing is what exactly is interacting, like there are bases, 4 bases, which one really interacting with the surface. And then you go to your next slide with kind of explaining that there was some experimental work showing that cytosine is more preferential, blah, 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 right?
Okay, yeah.
So looks like, again, your logical idea, which is very important, right? What exactly you're studying and why you are studying these things. Completely missing, right? So this is a part which you have to think about, maybe put it again in a bullet form, like additional slide maybe, right? And of course it has to be in a paper in your introduction.
Can you please give me one slide? Thank you.
And I do have my comments as well.
Oh,
And
okay.
I don't know, maybe other students have some comments. And this is very general, right, to everyone. If you if you will continue with introduction at some point, right, according to schedule, everyone will show introduction, or just a few people. I mean, literature review and introduction to the paper.
On Tuesdays, we will primarily focus on papers,
Yeah.
just sitting silently and writing something. But on Friday, it will be vocal presentations of literature reviews. Everyone will go through.
Yeah.
Yes.
So again, you really need to explain what is still unknown, right? What exactly you're addressing with your research, in general, in big picture. And then you can go to the details that, yeah, specifically we want to know how this interact with that, and then you go to the technical details, right?
Yeah. So this is that's the actually fact. We don't know exactly how they interact, and we need to figure out how the different combinations change the interactions with the nanocluster, as well as the single nucleotides interact with the nanocluster, because everything in combine change the fluorescence properties of nanocluster. So the empirical, they have some empirical results. They just synthesize this one using a single strand DNA. The one thing is they found most of the time they use a single strand DNA which has a more number of cytosine compared to other ones. So for example, one example I'm just showing you here. I didn't put the all reference here. I just put the number. If you need that, I can take out from the paper. So they use just DNA with the 20 cytosines and they synthesized the DNA nanocluster. They found out this is like a green emitter, but they don't know exact shape or exact number of atoms, kind of like things. Interesting thing is another study, they found that they can change these emission properties by using the tail or not by the precipitation one. Suppose like they synthesize the DNA and then they connected by pairing this another single strand DNA which has a more number of guanine, and it increases the red emitting flow or it can make it red emitting fluorescence, or before that it's like a darker thing. So guanine is doing something indirectly that can increase the intensity, but guanine cannot be didn't produce the fluorescence directly. So we need to know the effect of guanine in presence of cytosines or other nucleotides, because presence of other one, if you mix them together, it affects differently. So as same another example was a thiamine, but
in these cases, how big the clusters are? Like, do they know the size of clusters?
Yeah.
For these investigations, which you refer to, this more cytosine 20, more guanines, less guanines.
Yeah, I guess I forget the exact sizes. Maybe they did not put any sizes because they give us some range of the sizes.
But at least range of sizes.
Yeah.
So do you remember?
I don't know.
I don't know, 120, tens.
Maybe not that big. It's less than 100, obviously 100.
Less than 100?
Yeah, I guess so. But I need to confirm it. I'm not sure right now yet. And also, they have another study from the Jennifer from the national lab also. They also found that when they synthesize the DNA is very low white red emitter, but when they make it longer strand by adding the guanine-rich DNA, it increases the intensity by 500 times. Not the energy, just increase the intensity of this one. So it's make it bright on this case. So those are like a theoretical example from the experimental results. So in theoretical study, most of the computational study, they use the smaller cluster with one specific types of nucleotides, and then try to figure out how they interact on this one. And another, suppose like for the one study shows that, and another thing is I didn't include the experimental. Most of the another studies from the party groups, he suggested that most of the time silver plus, I mean oxidized silver cluster are favorable most of the cases. And in one paper he suggested that it could be the ratio of the size and silver plus is like 6 to 10. That means if your cluster size is 10 sizes silver cluster, more number of cluster are from 6 plus sizes. So there each are, but it didn't explain what is the exact reason of this one. This kind of statistical result they found by using the Poisson ratio. And they have a couple of number of studies they showing that overall the silver plus, I mean cationic cluster are more favorable in like more, and they have a more affinity to guanine and cytosine. And another thing is Z for guanine and C for cytosines, and I use T for thymine.
And again, because it's for the paper, right? It's not just literature review. You need, in a paper, you need really to connect and say, well, this was done, but this is still, we don't know, and this is what we will do, right? For calculations, especially, since they were already working on these clusters, right? Probably the same size as yours, right? And they already checked cytosine versus guanine, saying this is interact strong and so on. Right?
There's
so then the question is, and you kind of addressing the same things in your paper, then how would you different from this?
Yeah, actually I have some challenge here, but I did not put this in the slide. But in paper I read another paragraph why I'm doing this and what is the difference, what is the open question is still need to be answered.
So
yeah,
what is it?
Yeah, so in this case they got a cytosine rich DNA, have a, give more affinity to silver plus plus, and also they and the study they use this as guanine planar, not a single strand. But problem is what happen if you use the mixed cluster and every time they use the only one nucleotide ligands, either guanines or cytosines, but it didn't able to answer the whole system because experimental result they use a single strand DNA. There were more than 20 or 25 nucleotides. So in presence of other nucleotides or in presence of multiple nucleotides, it works differently. It can change the precipitation types, and it can change the solvent interactions because it's precipitated by the more number of nucleotides. And so that's in my study I'm going to try the overall study. First of all, what's the effect if we use the solvent? What is the effect if we use the more number of same type of nucleotides? And what is the effect of it if we change the different types? What's the interactions between the nucleotides can affect the nanocluster too? I mean silver cluster too. So those kind of questions I'm going to answer in this my paper one.
David, can I ask your vision? My question may sound aggressive, but it is not aggressive. I'm curious about it. How do you imagine it to yourself about the goal of introduction? There are two directions. One is to truly teach your readers what is interesting and what was done, what can be done. And second, just make a mark to a reviewer, like, I am aware of these authors because they work in this area. Because if you're going for second, then you do not need to give details. You just quickly, like, it was done green red emitters with this nucleotide, done. And if you really want to teach and explain, it needs to be more educational.
Yeah, in paper, actually this slide is a very concise slide from the almost 2 pages of introduction. So in the original paper, I mentioned that each group, what they are doing and what is the different result they found out. And I just give one example for here, like for silver plus affinity with the 3 different results and 3 different groups. And then what is the part is still that, they're just trying to focus on in the vacuum or all computational cases. But we found that vacuum, including the solvent, will give you the very different results. So it's important to include the solvent. And also another result they found that the affinity of the nanocluster with the nucleotide changes with the water solvent presence. So it needs to include, we need to include the, in all experimental, most of the time experimental, they use the in solvent medium, in the water medium. So we need to include the water also in the calculations. So I have one comparative study with the different conformations.
But again, for the literature review, for computations, right? So they were talking about affinity, interactions. Are they showing any effect of this interaction on absorption and emission properties in these papers? Because
they
you
have
do,
a one,
right?
yeah, in one paper in 2017 from which they use the one, they also calculate the absorption properties, and they just calculate for in presence of only one nucleotide ligands.
Okay,
and
so
larger sizes.
I kind of summarize what you're saying, but again, it has to be done very, very clearly in your introduction. After you've done this review, and again, I don't know, did he answer your question or not?
I've got his vision. Enough for me.
So then you have to say what was not done, right, still, and what exactly you're addressing, right? I kind of have 1, 2, 3, 4 points. One is mixture, right? Cytosine, guanine, thymines, when you have a mixture of all three or just 2 by 2?
Just 2 by 2.
Okay,
or
but anyway, so
yeah.
which looks like people were not really looking yet, and again, we have some understanding that this is probably exactly what happens in the real samples rather than just single type of basis. Then also effect of this mixture on a differently charged and with different various number of atoms, right? At least you go in with 5 and 6 means even and odd, because here we have a very different effect on spin states, right? So if we go with even electrons or odd electron structure, which again looks like there was some results on the charged systems, but without again addressing
the
different type of ligands, different type of guanine bases. I mean, sorry, mixture of bases. And then third one, solvent effect, which you kind of highlight several times. So you're saying that most of these calculations were done in vacuum. And the last one, I think, effect on absorption, like how this mixture really changing into that or to that side, right? So it looks like you have 4 points, and all of them connected to your literature review on experimental side, because when you explain what was done in experiment, right, you kind of still have to keep in mind and really put it somewhere in the sentence saying that, but this was not, but still unclear why this green or why is blue and what exactly is the effect, blah, 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 right? And then for calculations, after you're done with this review, you state like just 4 points, nothing else. This is good enough.
I guess 4 points, yeah, good.
So, okay, so this is your full main kind of
4 points,
things which you will address and which were not addressed in these ones, right?
Yes.
Okay. Are we kind of done? Or you have something else in your introduction?
And he has a slide in
and then you finish your introduction with a paragraph. Here we are, blah blah blah, and then you say addressing this and this and finding this and that.
Yeah, I didn't include that paragraph in the slide because it's kind of pretty common. Yeah. And these are actually more introductions part on my, but I did not elaborately include all introductions because I thought that I'm going to present the whole paper in this case.
The idea, well, it's so the idea again, we break it into parts, right? Same as we break in like figures, and we go just results, and just discussions, and just introduction. And this is really just to go through more detailed information in your introductional part. Again, focusing on what exactly the main points to address, what has been done, what is not, why is it important, right? And going kind of in a more details with review. Okay. So since you were the first one, right? So looks like probably not the best example. I guess people. Well, again, it's too condensed, right? Because you really
that's why did I.
This is a great example with great potential for improvement.
But it's a great potential for improvement, and I hope it helps you also to figure out. Maybe you have it in your draft already, which is good. If not, or even if you do have, you probably can polish it once again to check that it's really clearly stating what we discussed here, right?
But in my manuscript, is not maybe that clearly stated, but there have more information. That's for sure.
Well, it's more information, but again, we're not just getting into the number of pages in your introduction, right? Again, all this is really important exercise to organize, because there are many papers now you can find on the same subject, right? And your work as a writer to organize all these hundreds papers which you read, or I don't know how many exactly there, maybe not hundreds, but yeah, I would say close to 100 probably, if you finish with your numbering of your references, right? So to really organize them in a way that people really know how to deal with this literature, where they can, like if they focus just on these questions, they don't need to go through all 100 of them. They will just focus on a 1, 2, 3, and they already know what to expect from this review, right? From these papers, and again clearly explain the main points, what was done, how is it dealing with overall your main goal, and what really you will do at the end, different from them, right?
Yeah.
Any other questions?
Yes. AG plus. Through your introduction, I didn't got what are what are possible ionization states. Is it only singly ionized, single cation, or?
So yeah, they did not able to quantize in the most of the experimental result, and some experimental result they tried to. I saw that in Dr. Pati groups from the one, I forget the university name. He did a lot of different types, sizes, quantum nanocluster, and by using some statistical result, he suggested that silver cluster is most of the time form 10:6 ratio of the sizes. If plus, like if the 10 sizes silver cluster, it will form silver 6 plus 0. But this is kind of statistical result. So
is experimental work?
yeah, experimental work. Yeah, he used the Poisson ratio and everything, and then conclude that always 10:6 is the size and charge ratio.
Your question is like, you think that you need to explain some way in the introduction, kind of charge in a sense that why you, because you are not looking on a 6 plus in this paper. You will be looking just on 0 and +1, and maybe -1. I don't remember, or +2.
Oh, but I didn't include it in this paper.
So then it's 0 and +1.
0 and +1. Yeah.
Okay. So then probably you need to give some ideas why it's +1, why not +6 or whatever, why not +2 and so on.
So some people
we know we do have data with different charges, right?
Different
and we have
charges,
actually calculated this ionization and affinity energies and redox potentials, right? But this is for a different paper. But here you need to give some, like I think Dmitry, think about how you can put it in, like you have already this paragraph in introduction, but then it's immediately the whole for, or has a place for a hook of the reviewer to say, oh, wait a minute, he's talking about in experiments they see in like 10 atoms clusters might get up to 6 plus charge, and he's looking only on +1. Immediately the question is why?
Charging of clusters. Some people believe that it is one of the most important, or one of the most important properties of this silver photoluminescent clusters.
Yeah, we are thinking to write another paper on the.
But you need to include here some justification.
What is the reason to hide the truth? Even if you do not results, you can show.
Yeah, you say
open question.
Are important, right? However, here we're focusing on this and this, and then you need to put a reason why you're focusing on that and that. Maybe believing or something, maybe some other references that they claiming that their things are not charging. And again, they charge it for purpose, or they naturally charging. Like you do nothing and they are going to 6 plus, or they really ionize it with putting electric field or something.
I put this one for in this case because trying to define because in patterns of charge is the attraction binding energy will be changed too. They have a trans with the plus charge, and then the interactions of these nucleotides with the cluster is depends on the charge. If neutral cluster, the bind is change their interactions. It will also change the for
right. But my question is, in this paper where they do experiment and showing up to +6 charges, they charge it for purpose, like they really do something with their systems, or they just measure it and they see, oh, but naturally they can go. Oh,
they just measured in and got a plus charge. Another thing is, it also depends on the synthesis properties, because most of the time they use the some compound which has a silver plus, and then accumulate those silver and
Well, so far you're telling really that probably we need to go beyond just +1. We need to really go to the much higher charges. Right?
Yeah, another thing is conclusion
And
of this slide.
if we don't want to go this way, you need to find a reason to justify your approach why we're not really considering +6. First of all, I guess we can cite
one thing is
it was already a paper with Dmitry done last year, right, when they were really doing these charges and so on. So, but again, this is really kind of a good hole right now in your paper, where it's very easy for reviewer to ask this question, and then what? You have to do extra calculations up to +10 charges, or you need to find the reason. So it's better to do now.
Yeah, my mistake is actually, I think this plus doesn't indicate that 1 plus for my discussion is kind of with a more cationic cluster.
Okay.
Yeah, this is not the quantified, just quantitatively 1 plus.
Okay.
Yeah.
Please.
So I shouldn't put it actually just 1 plus, I should put the n plus. It would be a bit more appropriate in this case here.
But technically you don't go to n plus. You go to +1, just 1 plus.
Yeah, in my calculation, but for those kind of things, they just trying to quantify with a more positive cluster. Is more preferable, this kind of conclusions from this point.
So if the nano cluster is charged, how about the ligand? And how about the overall system? Is that still neutral?
Because nucleotides is over in a real system is just a single strand DNA. So that's why most of the time, and the metal cluster is more positively charged. And I took also NBU analysis, and those NBU analysis shows that metal core is mostly positive charge carriers, not the other carrier charge. It's also is very hard. Nucleotide ligand couldn't be charged positively or negatively because it's very easy. It's a long chain. So if it's positive, that charge accumulating in the core, not in the ligands.
I guess my point is, do we need some ligand to balance the charge to keep the system neutral?
No, the bases are neutral.
Contribute something to the discussion, maybe it will go quicker.
Yeah, I guess got it.
So the synthetic procedure is using salts of silver, and in this salts, silver is in cationic 1 plus. Then to induce nucleation of the clusters, one places in solution the reducing agent, borohydride. And if one puts a plenty of, it will reduce all silver to Ag0. If one does some tricks of putting just a little bit, then half of the ions are 1 plus, half of them are Ag0. And then they still nucleate, and there is a hypothesis that center of the cluster is 0 and surface is 1 plus. But balancing is not through immediate ligands, but through solvent, which contains this reducing agent.
And you have your data, where you're really looking on the charge distribution, right? So you kind of, he has an answer to your question. So it's an important question, but of course in experiments they cannot tell where the charge is.
Yeah, I guess he's curious because if we could get the positive silver cluster, where is the negative charge going? Negative charge is like an anionic part in the solvent, still in solvent, and in the real part. Because this is synthesized by using the sodium silver salt, like silver and boron with some compounds, those kind of things.
Good.
So, yeah, for if your introduction then is, I'm good.
No, you have heard.
I'm good.
Are these clusters amorphous?
Sorry?
Are they amorphous?
Yeah, it's more than amorphous.
It's hard to tell about crystal amorphous if you have.
And also it's few
atoms.
few atomic sizes actually.
They're not really, like, they're much less amorphous when
So-
they are without ligands. Like in that.
Basically, you have a cluster, outside you have some ligands, right?
Yeah.
Kind of.
So
They
I
have
guess the
different
question is,
And when you have ligands.
for
in
geometry
ligands, they have
optimization, you use DFT, right?
Okay.
So do you need to consider van der Waals interactions? Because the ligands are just carbons, right?
Yeah.
No,
I mean,
So one-
no,
no,
it's not van der Waals interaction.
no, no.
You're talking about metals. It's a coordinated bond with silver. They're really coordinated, like in the coordinated compounds, right? You have a ligand coordinated with silver plus or something.
Same
right?
as in metal-organic complexes with transition metals.
Well,
So
kind
no-
of.
this is-
Maybe
is
not
metal
not
now,
as
yeah.
strong, but it having kind of this nature of the interaction. It's not. It's really creating kind of a bond. It's
And
not just
also
absorption.
it's interacting through the more electronegative side, like here for is through the nitrogen, and this one not this part. So they have a lone pair electrons, and it's kind of more coordinated with the silver part, or metal core. So these are one of the kind of
But this is interesting discussion. But just don't forget, right? You will have a chance to see his results later on, and all your questions will be for that part. So then, because we still have a lot of things to do for today.
Yes.
So let's.
Yeah.
Any other? I guess all other people. If you have any question, you have heard the whole story, right? I don't know, John. Any comments on your side?
John was closing his face.
No. Well,
More questions one, more questions two, more questions three. Let's thank Jared. If you were listening and making comments, please return feedback. So, if you are here for more than 10 minutes, if you were here in the previous hour, you may start laughing. But if you just came, you will not laugh, probably. So let's. I have a couple of slides. First, let's congratulate Braden with Best Poster Award.
We did it already without.
And let's congratulate Dr. Han on the Lopin Award. So, who we are and what are we doing? So first, we are going very likely to have a satellite meeting, or maybe this will be satellite to another one, but second meeting on Friday, like 2 or 3, and maybe do the poll, maybe in person. We need to decide about time.
Maybe we can decide it right now.
3 p.m. Objections?
Well,
On what day?
Friday?
Friday.
I'm going to be working at the Math Emporium at 3, from 2 to 5.
2 to 5.
Yeah.
Monday. Monday is better than Friday then.
Well, I'm going to be gone next Monday.
I'm also.
Well-
No. One
We're
week
talking
doesn't
about,
matter.
we still have more Mondays, right?
Yeah.
So
We're
it
not
will be
talking about next
regular.
Monday and spring break, right? After spring break. Yes?
You got to think.
We might mainly really kind of
Consider as a
restricted
as
by
a regular
undergrad
schedule.
students.
I think
But
Mondays I
does
can
it make
do
sense
later.
to have 2 meetings like right
Yes,
now?
yes.
Yeah?
I will announce why. It's really. We
You
have.
have to repeat it, right? As you are non-self
There will be a hard time. So if finding time is a challenge right now, let's do doodle poll, and someone of us who is has most energy.
If it's challenge right now, doodle pool will not help because we will not have overlaps. So again, anything's going on Monday with you, or Monday is more or less okay, wherever your time would be.
I
2,
could-
3, 4. I
I
don't
could
think
do
we want to
12
do
to
later than
1.
this.
Is it possible to do Wednesday and Monday, because actually more
No.
have a conflict.
The reservation is not easy.
Yeah, there's
So if we give up this one, there is no guarantee that we will get another.
But then I don't understand. If we just will be sitting here and doing the things without discussions, why do we need these connections then?
We may do it without connection. We may. But John then will not see what we do.
Well, if we have second.
So how many people have troubles on Friday?
I mean, I have troubles every day depending on what
Okay.
time this is.
Okay, because right now there was only one objection from London.
or
about Friday.
can we start in early time in Friday, like 1 or sure.
I have class at 2.
Finishes at 2 or starts at 2?
Starts at 2.
So by 3?
Yeah.
I also have a meeting by 1 and I want to eat after that. Otherwise I will be not eating for the entire day.
I could do 1 to 2 or after 5 on Fridays.
I'm not.
After 5 is great.
It's Friday evening.
That's all I got.
We do
Otherwise,
have-
like, 8
I think it was Siva who was doing group meetings on Saturday. Because of the students were not able to
Could we
find
do
time.
4 to 6? Then you could be there for at least half of it. And then we could still kind of get out of here faster than.
Would it take 2 hours?
Well,
We hope it probably will stay not longer than 2 hours at least.
But
Maybe 1.5 hours.
What are Mondays and you have the option? Oh,
Well, let's decide what is better, Friday or Monday. Looks like
It
for
could-
Friday,
Completely depends on the time.
well, we're talking about after
both
whatever you're
4 to 6 Monday or 4 to 6 Friday.
trying. Can be 3. Why is it 4?
4 to 6.
4 to 6, I'm in the Emporium on Mondays.
Then what is your available time?
On Mondays?
Yes.
Okay, I'm busy 8 to 9.
We're not doing
Well, we're not talking about morning.
Right. Well,
After lunchtime.
I'm trying to remember because my schedule is just like all over the place. After lunchtime? Okay, so I got class from 11 to 12, so I think, let's see, 12 to 1 I'm okay, 1 to 2 is my office hour. 2 to 4.
If I can throw
I
a
think I'm
preference
alright.
out there, I'd
2
rather
and
do
4,
it on
okay.
Friday.
2 and 4 on Monday as well? For you? 2 to 4?
I'm free on Mondays, but I have like all of my assignments are always due on Tuesdays.
So you prefer Friday?
I would prefer Friday.
I would prefer Monday, but
2 to 4 will work?
as long as I'm not stepping on toes.
So if you do on Monday, we lose London.
And then
No,
I,
we will
No,
not,
no,
because
no.
you can do 2 to 4.
Yeah, 2 to 4 I
I
think
could
I'm
be
Monday
here
2 to
from
4?
3 to 4 because I have class.
And then we will miss physics seminar.
Oh,
No,
yeah,
it's
never mind,
not.
screw that. Nope, I'm out on Mondays.
Oh,
Yeah, that's
yeah,
no good.
Mondays
I
is
thought
no
there was something there.
Most of us are not coming there, so we will not mind. But
Because then maybe from this point of
What
view,
about
so we
Wednesday?
have a choice, and after 4 o'clock,
I work
Monday.
at the Math Emporium from 4 to 6 on Mondays, and then after 6 I'm free.
and for Friday, 6? Okay. So looks like you're probably better with Friday, you said 4 to 6, and you probably will be late by half an hour or something like that.
I get out of the Math Emporium at 5 on Fridays.
okay, so you'll come same as on Tuesday for
Yeah.
last hour.
Well, maybe for last 30 minutes. Okay.
Yeah. And this Friday we do not do.
No.
No, it's still for us to adjust on the full schedule, starting next week.
So Friday, 4 to 6.
Yep. Okay. So, who we are and what are we doing? Many of you have visited Sanibel Symposium and got feedback and wrote your.
It's all of us, right?
Wait,
Yes.
wait, we're starting next week then on this? I thought they weren't going to be here.
It's okay. They will be not here, but we will start.
Okay.
All rules have exceptions. That's fine.
Okay.
There are 3 people.
We
who
care
are
about
missing.
like 2 months, and 2 months minus 1 week is still more than enough. So all participants of Sanibel Symposium are getting a privilege of submitting proceedings on which there is no label that is proceedings. It is a true peer review paper. All of us need peer review papers, which means it will come through procedure of reviewing, blind reviewing of unknown people, right? In order to submit and get accepted, it should be exceptional quality, not only of science, but also of writing. And even if you do have exceptional science ready as your results and your posters, converted into writing that will come through reviewing is a hard task. So we will do an effort here as a group to convert work of everyone into competitive manuscript that will be submitted either as a proceedings to Sanibel Symposium with a due date of last day of April. So literally 2 months after today. Or if through internal discussion inside the group and with opinion of whoever is your advisor or group leader, a paper that will be prepared with the same deadline can be submitted to higher rank journal. But let's try our best effort to complete a manuscript per person in 2 months. Okay? So instead of sitting 2 months and writing in silence, we'll split manuscript on fragments and prepare one fragment per week, bring it to the group meeting, and make a collective editing. What is collective editing? It means each author prints whatever, 10 or dozen copies of the fragment that we are improving, distributes among everyone, and starting from then, everyone starts playing role of fake reviewer, or friendly reviewer, or unfriendly reviewer. So reading and providing feedback, trying to do it as critical as possible. In order to simplify this task, there will be some hints what to look at. So if you look on the plan of the meetings for the rest of the semester, you will see this splitting of your future papers on fragments. We are going approximately in the reverse order. Figures, then results, then conclusions, and make an introduction as a very last step. Because there is no reason to write introduction if you do not have results. Okay. So next week, please everyone bring your figure section. Some of the volunteers have already prepared figure sections by today, and there is a dual benefit of this. First, those who are doing it for the first time will look and take as an example how to do or how not to do. Second, we all as reviewers will provide feedback, what we like or dislike in these figures, and return it to authors for improvements. Again, if you're doing it for the first time, the same, you expect the same towards your work next week. Okay? So right now we are speaking only about figures, not about the rest of the manuscript. We are helping each other to avoid unnecessary criticism of reviewers. So we criticize each other, improve, and then get nice ratings. So criticize now is better than getting criticism from reviewers. After we complete this procedure, every of us who was playing role of reviewer returns the feedback to the author. So the author can look on it and implement improvements. Look on the comments and implement improvements. So what to look today for the figures? So if I am illiterate, if I'm looking only on figures, I look on them and see, do they look logical? Can I get main idea of the research without reading the paper, just looking on the sequence of figure? If I'm not satisfied, if I see that they are in the wrong order, I mark it to reviewer. And today we have very relaxed schedule. We'll have half an hour to look for 3 papers. That's nothing. Typically we'll have like a dozen papers in a limited time. Therefore, sometimes there will be no time to go and edit, write marks on the actual paper. But at least you can make a little marks on this forms. So it's a like minimal thing to do. So you mark, I do not like your order. Swap the order. Make first figure last figure first, or whatever your intuition tells. Then nothing about science at all. But you do not want to have your paper turned down because of the poor formatting. So most of us, including myself, try to write with tiny little size 8 comment inside the figure, which you will not see, and reviewers and editors will pick up on this. So do not hesitate to do huge fonts for labels, legends, and do the same font across the figures. If the author doesn't do it, make a reprimand. Tell like, work on your ideas. And if number of figures is too large, some people do panels, right? So panels are typically labeled alphabetically rather than writing top, bottom, left, right. There is nothing wrong scientifically, but it may irritate reviewer or editor. So each figure is accompanied by captions. Caption is a little story. Do not hesitate to make it long. Do it as in the kindergarten. In the first line, I see blah, blah, blah. Second line tells this. So if there are any labels, any symbols, explain them. So that lazy people who do not read the rest of the paper, and there are many people who judge paper based on the figures only. Because they are bad, lazy people, or maybe just lack of time, objectively. So caption below each figure should give enough information to understand the figure. So guide reader what is seen. Summarize mechanism what you see. So if you are grading through a paper, reading caption and do not see enough explanations, make a note to author. Please expand your caption. Very, very rarely you can advise your caption is too long. You cannot go for one figure, 2 pages long caption. Typically, please, 1 line is not sufficient. Give more details. Size. It's all same about thickness of lines and fonts. If you have seen, and I have no doubt that you have seen through papers and published in papers, your nice figures are shrinked, zoomed out to like 1/8 of a page. So whatever content you place should be seen after substantial reduction in size. If you have some small fonts or tiny lines, they will not be visible. They will be like white, nothing. So make a comment to authors. And if there is not enough figures, right, please add more figures. If there is too long, right, I'm tired, you have too many figures. Send unnecessary details into supporting information. So today, each published paper has a section of supporting information where you can put any information that you're not sure about its importance. And it is unlimited. You can put 50 figures into supplemental information. Okay, I'm done. So we do have 3 papers. Each of them is accompanied by the form. We do have 30 minutes, about 10 minutes per form per paper to complete and return to the author. You will recognize who is the author. If you will not, just ask, like, who wrote this masterpiece?
Is there a special order with that, or
No.
choosing
And
their preferential
if
order?
we never made a promise to be silent. If you disagree something or you want to give a comment, just approach the author and tell her, I'm lazy to write all of this, but you're wrong. Or if something is unclear, feel free to interrupt.
This one paper. Is this 1 or 2 here?
That is 1. I think. You see. That might be 2.
Do you have a stapler? Someone having a stapler? No? No one having a stapler with you?
Nope.
Mine ran out of staples today. Mine ran out of staples today.
We'll bring dozen staples next time. I'm already done with the first one. working and writing, then do not listen to me. If you're bored, I will attract your attention and make a comment. So it's not well. When you read and write a paper, the homogeneity of logical information is very important and helps reader. So it's better to say everything you can about one subject and then jump to another. If you have subject number 1 and subject number 2 and you interlink them, the reader, editor and reviewer will hate you. Do not do it like system 1 has this DOS and now I tell it something else, and then by the way system 2 has different DOS. So if you have one property like density of states, make one figure for all systems. Like figure 1 geometry, figure 2 for example density of states for all models, figure 3 optical properties for all models. It will be much easier to read for reviewer.
done only one. I even didn't finish it.
The rest will be much quicker.
This is the magic projector.
Yes.
Then what do you mean by U2 coupling? There's no coupling when you're showing this kind of figures. They're not coupled with them. You just a derivative trajectory.
Aren't the energy states coupled to
They're
vibrational
not.
modes?
Not here. You calculated right. The coupling is calculated based on this. First coupling is trajectory. They're not crossing. This trajectory. This teaches it has no rights to jump. This is a derivative trajectory.
I guess I'm not sure what language to use, so I guess like these two states, they're the Mn dopant states. So I assume that the vibration is due to like orbitals on those
No, no.
Mn bonds. Right.
Your fluctuations, you have your trajectory which having some complicated surface potential, right? And you like this is your state, let's say S1,
Mhm.
first exact state of
Right.
so you really follow this kind of complicated trajectory, and that's kind of due to the whatever the motion, right?
Mhm.
But coupling electronic with bidirectional is when you go from one trajectory, let's say from the ground state to the first exact state, or from Luma to Luma plus one and so on.
That's not what I meant. Just it's oscillating from
Right.
the potential.
So it's like
That's yeah. I'll be careful in that.
so it's not coupling, just due to the vibrations, due to the thermal motion, right?
Okay.
why does this start over again?
Oh, yeah, it's just gonna be optional.
Is it one or two papers? There are two figures, one, figures two.
I think it is 2 papers. It's like in a supermarket. Oh no.
Three papers.
No.
No?
This one completed and this last one. Can you give a number?
Can you pass this up? I can't carry it. It's very fun.
But you consider that for each line for different. In fragment means everything is same, one program. But you plotted separately for each molecule, right? You have different color lines for different molecules. So you separate.
I can be your best post.
Fragment means everything is fragment. One element. Suppose like each system, you have one element. So number of moles is 1 mole, but number of fragments is 2.
So, is it complete our session soon? Just speaking of flow, you're still. So, why not bring in your paper today? Or if you're not on the meeting, because then I'll have to please consider to follow the same form and bring your paper next time. Or if your schedule doesn't allow you, just
friends, your friends will help to you, and we will keep the wheels rolling.
Yeah. So how many materials? There are 2 fragments, 1 in fluoride.
Yes, let's just try to do it.
Да, расходим сейчас. Сейчас посмотрим.
Now, as time goes by, this one,
Not this one, I mean this one only.
5.8.
Okay, I think some of us are making the very last comments, but the time is up, and some of us have other duties.
I just add up.
So let's announce completion of the meeting. Return your feedback to authors, and looking forward to see you next Tuesday and Friday in 2 weeks. There will be an attempt to make Fridays also online available. Okay, well, I don't know if there is a reason to upload to our viewers, but I am thankful to everyone. Okay, meeting is done. We are going off
So
records.
what's going on next Tuesday then?
Next Tuesday, same thing for the rest who. Is there anyone to John? Do you present next Tuesday? Okay, so it will be same schedule as
I'm
today.
planning on it.
At the beginning, John presents literature on his project, and the second hour we do review on the rest of figures who didn't bring today. Yes.
Do you want me to come up next week?
Up to you.
Ask your boss.
Up to you.
Yes,
if you want,
that
you
was
can
more
do
directed
Skype
to her.
presentation.
Okay. All right. Well, I'll probably be in touch this week about that potentially. So.
Well, depends probably on the weather as well. Right?
Very true.
Yeah. Well,
Very true.
if the weather will be good, yeah, if you can come, it would be great. If not, then we do just Skype.
Okay.
Okay, and authors who got feedback, please implement these comments. The sooner the better.
Meeting adjourned?
Yes, yes. Meeting adjourned.
So after the, suppose like after 710 content, how many fragments
For
is
the
there?
grant information for the reimbursement, is
I need
this
to
in,
call.
is it on the approval thing for the poster, or is that the same thing?
Like I didn't really get any results.
I
I
don't remember which grant you are on.
Okay,
And if you put a different grant, they will ask a question why you're working on one grant and you are covered by the other grant for your travel. So I need, and I don't remember honestly, so I need to probably talk to Fiona first and ask her where you are,
okay.
or maybe shift you, and then, so let me,
That's
yeah.
my.
Okay, so you'll just get back.
Send me, yes, but send me just a reminder because I can forget, so I
Yeah.
will try to do it this week.
Okay.
So let's say if you don't hear anything from me tomorrow, after tomorrow, don't hesitate to write an email and just say, what's going on with my grant, this information.
And then, I'm assuming that when I'm like,
So for next
You're
Tuesday,
saying the number of fragments.
you have your figures which you already have on your poster.
yeah, exactly.
So now, like, they are kind of, you can just need to break them in like figure 1, figure 2, figure 3, right? So now we can divide all.
Yeah.
And then send it to Dmitry by next Tuesday.
Okay.
He's going to do the first draft for this series as well.
Okay. So if I get all of my
Because
obviously
this
like
meaning,
I've
that
written
means
the
number
paper,
of fragment
so
would
I
be-
feel like my
you have to-
Yeah, that's why we do it.
Yeah. Okay. So do you want to read over them before I send them to
If you
him so I can edit it on Monday when I'm
But if
working,
you
or
count the number of
do?
I think we probably, I would say let's do it in the opposite way. So do whatever you want to, how you think would be.
Like I don't.
Then get the
These has
messages
more
from people.
Okay, yeah.
And then we can discuss it and reorganize later on.
now
Like you will try to
each
address
of
this,
them.
or we can discuss
How
it.
many
So
of
we,
them are
like
there?
first,
How many
Like,
of
just
do by your
them?
own, whatever you think would be the best,
Uh-huh.
because you probably have your
If you
own
see the
plan
number of
already.
fragments,
Yeah, kind Kind of,
We
yeah.
were discussing it on the poster, so you kind of know the order, you know how to kind of represent this and that. So organize how you want to do it, because it's your paper first of all.
Okay. And then
And then if it needs to be changed or and don't forget you also probably need supplemental materials, right? Because some things will go to supplemental materials.
okay, I'm not 100% sure what exactly that is.
We need I mean, like you were doing some, like you remember, like your doors.
Yeah.
We just showing the most representative ones, but you have much more of them. I would say this.
I feel like I would have to actually like.
Have to organize them maybe as columns in one page. Hopefully, it will be just one page.
Because like I just
not
don't
maybe
understand
two
like why
pages.
a journal.
And this is will go to supplemental materials, which is
Like,
in addition, like your paper, and then people go to the link and get this
More.
additional materials
Okay.
if they need, right?
Okay, so should I have those ready for Tuesday as well, or should
Well,
I?
try as much as you could.
Okay. Alright.
But if not, we can do it later, but I think it's better to do this once set, so you know, here is, because when you write paper, right, you write not only about only the things which you show in your figures, this is your main, it's your main plan, right, so you say, oh,
Yeah.
my dose is blah, 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 as the most representative for this figure to it, something. And the other structures behaves kind of in the same, in agreement, C supplemental materials S2 supplemental S, right?
Yeah. So they know that you're not
S2,
just
CD,
like.
and so on. So you have to refer to your supplemental kind of, but it has to be one story. It has to, like you don't suddenly at the end say, and by the way, there's other structures shown in supplemental. It has to go in the same place where your main figure is, right?
Yeah.
So that's why I said like when you create it, so kind of it would be better to do it together. So you know, oh, here is like. Here I
Here's
know
what I
what
wanna
I'm
show,
talking
and
about
here's
because this is
the
my main
extra.
points.
Got it.
But it's not just for this specific structure. All others behave in
well,
a
it's
like
just like I feel like I should
not
get
only the solvent, the other
some
solvent
results
behaves
that are
very
at least
similar.
like somewhat
And then I just have one more
close,
quick question.
right? Like at
So for
least
the
like
figures, it's just
moderately
explaining like what it's
accurate-ish.
showing, not
I mean,
like that interpretation of it.
Well,
right?
there are two approaches. You can go with a short version where you just explain what's shown in a figure and don't use the words left panel shows.
Okay.
You just say that's your states of blah blah blah, and then A for this structure, B for that structure, and so on, right? So you don't like it has to be short and just a statement, right?
Yeah.
And first you do this, and again, the main idea you start with the first sentences. Like say you have A, B, C, or how many panels, right?
Yeah.
So it would be good to start with a sentence which kind of summarize the whole figure as just, I don't know, like for example, density of states for quantum dot ligated by this and this ligands, right? And then you go A in this solvent, B in that solvent,
Okay, but
D.
it's not like interpreting.
Okay.
the-
But first
No,
you
I just
start
feel
with,
like I should
no,
do more.
well,
It's like
it's
I really didn't
you
do
start with
that
description
much.
first,
Yeah.
like general description
Uh-huh.
for the entire figure.
Yeah.
Then you go into the details A, B, C, and let's say if you don't show all this information in your legend, then you probably need to say dashed lines and these solid lines, blah blah blah, right?
Yeah.
And then it's also just for like as you did for your poster and as we discussed when you were doing your kind of drafts, right? To write one sentence very short, like the main idea. Like for example, I don't know, this ligand show in trap states and this don't. Or something, right? So you kind of summarize the main point. Again, it's more for you, and technically you can do it really more extended at that stage, because then we just take this and put it into the text and decrease the caption, right? But you will have already your ideas what exactly you. It's like planned, right? So you have some ideas what you are talking at this when you will
I guess
discuss
I
in
just
these
don't
figures,
like.
right?
Okay.
And what is your main point to
I don't know,
discuss?
from like
Yeah,
the
that makes a lot of
publisher's
sense.
point of view, I just don't
I
know why
think
they
that's all.
But I would say like the first you start with
I
just
mean, okay.
explaining what's going on
So, I
your
mean, it
figure.
seems kind of like obvious
And
to
then
me now
in
that I know a
addition,
little
you
bit
add
more
in
about what's
one
going
or
on
two,
that,
how
like,
many
that
sentences you
shouldn't
want to,
work, really?
with
Because I mean, there's just
figures
so
that
many
will
things
probably
that
will
I'm
reduce it
neglecting. I mean,
at the final stage,
You can
right? Because we don't want to have caption to be
Yeah,
very,
yeah.
very long. But for now, I would say you probably can have more. And you already seen this people like, I think Moon has really very short kind of captions, right? With
Tutano or not Tutano?
minimalistic
1D
kind
or
of
not 2D?
information.
One,
Erin
there
had,
was a
there's only
paper
two people whom I
similar,
had
not yours.
Yeah.
had enough time to go through.
How many
Erin had
dimensions
more like
would it-
really more open discussion on what's going on with his figures, what is the main whatever point or so on. So as I like, it probably will
And
be
it is
reduced
nice
anyway,
yeah.
but maybe it's a good idea to have it, at least one sentence to have it for yourself. To be sure that, oh,
This is what
this
I'm
is
trying
my
to
main
show.
point.
Okay, yeah, that'd be
And again, in your supplemental, you have all other things. So because you have a lot of that, right?
Yeah. Yeah. Okay, awesome. All right.
And there are some things with your. So you will come. I forgot Thursday
Yes. Yeah.
at 3.
I come at 2.
Or 2.
Yeah.
Okay. I will try to read. So because there was some issues with your optical spectra, you remember my question?
Yes. Yeah.
I would really like. I thought that I will have time to go to your post and discuss it with you, but you were busy with something. I came in and we were talking. So okay, rather go. We'll let you just
Yeah.
enjoy.
Well, no, I would love to go over that because obviously, like some.
Yeah,
that doesn't seem
but we probably need to go through it. And as I said, like I will send you the draft from Nadine
Your call will be disconnected.
just so you know, like again, not as an example of really, because it's also very, how to say, fresh draft. It's not finished yet, right?
Yeah.
But it probably helps you just to get the
So do you want me to try to
kind of
like
idea of
email
what's
you
going on,
some
right?
Yeah.
figures in for
And
next
probably
week
also
and
compare how much your data
Even if you are
supporting or
Because I
not
wouldn't
supporting
be here to,
his,
like, do
his
this,
data,
I guess,
just
but-
comparing figures, and then in a discussion, are you online with us, like seeing the same things, or maybe it's completely different?
Yeah. Yeah.
And it looks like your spectra were kind of opposite to what
Yeah.
we expected, so probably we need to discuss it a little bit more.
Yeah.
So, the grant information, I will also email you the paper from Nadine, and which you have to, it's pretty short, so it's very quickly, you will read it.
Okay.
Mainly again, look on the figures, and they're pretty much the same as in the poster. And what else?
I think there's
I
pretty
guess
much it.
that's it.
Yeah.
Yeah, so 2 things from me.
Okay. All right. That sounds good.
And probably we'll have a short discussion on Thursday about Spectra.
Yeah.
And you will continue working for the Tuesday. Did you catch up with your?
Yeah.
I forgot. Oh my God! I forgot to email. I thought I did. I forgot to email your quiz to your professor.
Oh, I mean, I'm sure if you have it, then like he knows that I took it. Like if you say that we took it on Friday, then it's fine. I don't think it matters too much, but.
But did you have it today?
At some point, remind me.
Did it ask you yet? Okay, I will-
I
I
had it
will-
yesterday and today, but it's fine. It's not. I don't think it's a big deal.
I think I have it.
Okay.
I for sure have the
It's a
exams from Austin and Chris.
Yeah.
Yeah. No, as long as you say that, like I took it on Friday, he's not gonna care.
Oh, you met
It's,
exam?
what?
You met exam?
Yeah, my quiz. Yeah, it wasn't. Yeah,
Paper quiz or online?
it was paper, but my my grad student grades it anyways,
Ah,
so he's not gonna care. Yeah. So, yeah. All right. Well, I have to go, but I'll see you on Thursday.
So I have a couple of questions actually. One thing is for Daniel. I talked with him like at that time when he said that he will come and he interested to work on that, but he did not. I told him several times, but he did not show up eventually. So
we need just to put deadlines. If nothing happens by the deadline,
okay.
I'm going to
then we just.
go to Costco and buy stuff for the
Oh,
business.
okay. I mean, yeah, I don't know. So that, he did not tell me anything, but he was in our lab to work on operational
Yeah.
chemistry, some homework, those things, because his lab doesn't work.
I don't care.
Yeah.
He can do whatever he wants to do there. Not a problem for me.
Okay, I have some question about
Okay, yeah.
Oscar.
He also
But this is
didn't.
not counted.
So, basically this is my plan.
Because
So,
again,
basically I'm going to find a unit cell.
I think
that
once
just
we
make a
need to
slab
kind of focus on these things
and some
include the-
vacuum.
just make
Yes.
us
So